How does a processor find a small sequence of bits hidden inside a larger binary number? Today we will see how ARM7 detects whether a 4-bit pattern exists inside an 8-bit data value. Imagine we receive an 8-bit binary data. So this is our data. Now we want to search for a smaller bit pattern. Let this be our 4-bit pattern. Our task is to check whether this pattern is present anywhere inside the data. The processor checks the data using a moving 4-bit window. First, it looks at the first 4 bits. The selected 4 bits are compared with the required pattern. If the pattern is not found, the window moves one position, then it checks again. This continues until every possible 4-bit group has been tested. Since our data has 8 bits and the pattern has 4 bits, there are only 5 possible locations. When the extracted 4 bits become equal to the required pattern, a match is detected. This method of moving a fixed size window across data and comparing each section is called sliding window pattern matching. This idea is used in digital systems for detecting specific bit sequences, identifying data packets, communication systems, hardware pattern detectors. Now let's see how ARM7 performs this operation using shifting, masking and comparison. Before understanding this code, let's see if it has any errors. No errors, so we'll go ahead with debugging. Very first thing that we notice here is the assembler directive area, which defines a section of memory to store this information. Pattern is the name I have given for that section of memory. Code indicates this information is nothing but actual ARM instructions. Read only because we don't want any modification to be happening to this particular code during runtime. Entry indicates where exactly execution starts. Execution starts at the very first label that appears after the assembler directive entry. Start, check, found, and done are nothing but labels. End indicates the end of source file. We are using register R0 to hold our 8-bit data, register R1 to hold the pattern which needs to be matched. Register R2 will hold our final result. Once we finish executing this code, R2 will hold a value 1 if there is a match. R3 keeps track of the current window position. It starts from 0. Now let's see all this initialization happening. Inside check, since there are only 5 possible locations, that's the reason we are comparing R3 with 5. Internally, subtraction happens and based on which the CPSR is updated. As of now, R3 is actually 0, because of which this branch will not occur because the EQ condition checks whether Z flag is set as 1. That's not the case, because of which this branch will not occur. In the next step, we are performing logical shift right on the content of R0, but R3 is currently 0, because of which this results in the same value as our original R0 content, and that is placed in register R4. Here we perform AND operation between R4 and the immediate value F. What this will do is it will extract the very first digit, or in other words, the last 4 bits, and places it into register R4. So you will see the value 5 in register R4. Now we are comparing if this content 5 is equivalent to the content stored in the register R1, which is A. If they are actually equal, we will branch to the label found. But that is not the case now, because of which we will just increment R3. We have already checked one location, and in that particular location there is no match. Okay, so now we branch to check. So here again we perform the comparison. it's not yet 5, because of which Z is still not 1, hence this branch will not occur. Now we perform the shift operation on R0 by 1 bit position. The result is now stored in register R4, that is ANDed with F, and we compare if there is a pattern match. Since that is not the case, we continue incrementing R3. This continues until the content of R4 actually matches the content of R1, or when R3 actually reaches the value 5. Okay, let's see that happening. As we can see here, the current value of R4 is A, which is exactly same as the value in R1. So now what will happen is when we compare them, Z flag is set as 1, because of which we will branch to found. Here we are setting R2 as 1. And finally we jump to an infinite loop. That's all about this code.